access to GPUs. Okay, so maybe for the test sort of thing, it's completely fine. But when it's not a test sort of thing, then it's not fine. Okay, and how do you enable GPU? If you remember, yesterday we didn't enable GPU, but you can basically go into your runtime. Okay, and then you can you will see in here, okay, change runtime type, okay, and then you can select a GPU. In here, if you see, I have selected this T4 GPU, which is basically available for free. But if you pay it, you might be able to use some much more advanced GPU, okay, in it. So I hope that's clear to you guys, right? Okay. Okay. So what did we do? What did we do? What did we do? So just to show you, I actually uploaded this whole dog breed identification zip directly onto my Google Drive. You get 15 GB of space for free. So you have to be careful on the space, that how much you have available. Okay. I uploaded somewhere around 700 MB of it, and it works completely fine. But this is zip file, and you have to understand that we will have to unzip it, okay, to basically functionally work on it. And gladly, Python actually has certain functions that we can just use out of the box to unzip it, okay, which is this whole unzip function, okay. And I say it like, give it the path where it is supposed to basically unzip all the files, and that's where it has unzipped all the files present in this Google Drive, okay. It takes some time. It took me like roughly 18 seconds or so to unzip all of that, okay. And then we just check which version of TensorFlow we have. It is 2.15. Which version we have of TensorFlow Hub? It is 0.16. This is all we actually ran yesterday, but it was not really working because we didn't do it, okay. And then finally, if you see, we have just copied part from here. You can just copy part directly from here as such. And we just need to copy and paste. And the first thing that we are trying to analyze is labels.csv. Yes, it is from last session, but we didn't get the chance to run it, and I just ran it. And that is why I'm just explaining you it again, because we were not able to run it. Okay. So this is all the things that we have already done, analyzing data via pandas, right? This is we have already done. You have seen it countless times. And this is what we are doing here as well. Okay, so what we say, if you remember, with pandas data frame, we can describe it, we can get head. With head, we can get like first 5 sort of elements by default, and this is how the first 5 elements look like. By describe, we can get like, okay, what is the count of ID, what is the count of breed? So you see that there are like roughly 10,000 data points. How many of them are unique data points, and so on and so forth, and which one is the top one, what is the frequency. So a lot of data that you can get around it and analyze it, okay. Finally, we try to plot a graph, okay, based on top of breeds and the value count, okay, for each of these breeds. And what is value count here? Because the idea is how many times a particular breed is being repeated, okay. So that is the value count. So how many number of those breed size that we have. And if you see, there's so many different types of breeds, and some has 120, then 100, and so on and so forth, okay. And we have plotted a whole graph here which showcases like we have bunch of breeds, and then based on how many number of those dogs we have, we are basically having that. Cool. Okay, now what we can do, we can actually view the image, okay. We can view the image, and we can use something from IPython display, okay. This is just given to us out of the box, okay, in the Google Colab. And so, okay, the path is wrong. Actually, I need to get the path from here. Ooh, 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 ooh. Cool. And if you see, we have pictures like this. There are a lot of pictures like this, and this is one of the pictures that we have in this particular data set. Okay. And the idea is we want to classify this data set, okay, using TensorFlow. So that's the basic idea around it. Cool. Um, so let's try to have some sort of logic around it to get like file names, okay, of the data set that we have. So what we'll do is like we'll try to create. You can just ask the question, type the question right out of the box on the chat. So create path names from image ID. An image ID is something that we have. This ID is what we are getting here already. This is the same ID that we get here in the labels. Okay. So each label is basically signifying or denoting a particular image. Cool. So we can do that. So what we'll do is, for example, file names equals, and then we can basically say train here, right? And then we can get the file name, okay, f name, which is okay plus .jpg, and this is an inline. If you remember Python classes, we did this whole expression stuff, single line expression, iterable expression. We have already covered this. Okay, so we are saying on the right hand side, on the left hand side is what where our logic is, and on the right hand side is our loop. Okay, so for f name in all labels.csv, which is this whole data frame, we're iterating over this whole data frame, especially the id column, and getting the ids, and which is also the file name for each of these images. Okay, probably we did something wrong. We did something wrong. Content dot breed identification train. I mean, we did something wrong or what? Okay, we have labels dot csv. Cool. Oh, we did it right, but we didn't even print it. Cool. So let's just see what do we have in here. And you see now beautifully that we have path to a lot of these images. Cool. Okay. Now we need to check if number of file names matches number of actual image files. Okay. So we write some Python code, and what we are doing in here is we are checking if number of file names, okay, which is present in the training data set is equal to the file names here, and if the file names actually match. So let's see. And it says file names match actual amount of files. Cool. Okay. Now we need to do one more check, just to check on like if the breed and stuff is filled in. So let's see. Let's see. Are we getting something cool? And maybe we can check if it is a Tibetan mastiff. Okay, let's see the image. Oh, it is. If you guys don't know, this is basically Tibetan mastiff. Okay, so we know, okay, the data somewhat sort of looks right. Okay. What we want to do is we need to prepare our labels. Okay. So the first step actually is to actually convert it into numerical form, right? And what we'll do is we can use NumPy and we can convert our data frame, especially the breeds column, into a NumPy sort of format. And then we get a NumPy array, right? This is the NumPy array, correct? And we can see if this matches the number of elements that we were getting earlier, which was somewhere around 10,000, and yes, it does. Cool. Now, we can do the same check if the number of, if these number match. And yeah, number of labels match, number of file names. Cool. Now, we need to find how many unique breed labels that we have. Okay, so using NumPy has a function where like we can basically identify the unique labels which is present in an array. Okay, and then we get, okay, we have somewhere around 120 unique labels in this whole array because we don't really need a lot of these labels around it. So what we'll do now, we can just see, okay, what are these unique breeds? And you see that, okay, there are like bunch of unique breeds, which is obviously a data type object, right? Okay, now what do we what should we do here? So to make our lives easier, what we would like to do is basically convert every label into some form of Boolean, okay, and eventually into a numerical form. Okay, so let's try to do it. Let's try to do it. Cool. And we'll have this labels here, and we'll see, okay, we have a lot of false labels because we're just equating the first one to like everything. And if you see that the only true one is like the one which basically is true, that is present in the label 0. Okay, that's why we are getting basically only one of them true. Okay, um now this is a sample example on like turning Boolean arrays into integers, and this is how we will technically turn Boolean arrays into integers. So before that, actually, we need to initialize Boolean labels. For example, these are our Boolean labels, a lot of like true, false, 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 false. Okay, and we can turn Boolean labels, which is like all false and true if it belongs to that particular thing, into integer. So using NumPy. So index where label occurs. Okay, and okay, so where it will be true, it will just have, we will have one instead of true or false. Okay, and if you remember, to analyze any model, we actually need numbers. Okay, we can't deal with uh, per se objects. We need numbers to analyze those data. I believe that is somewhat clear to everyone, right? That is clear. Okay, so I hate it when it does not really work with like Jupyter shortcuts. Okay. So now what we'll do is like we'll create our own validation set, okay? Since the data set from Kaggle does not really come with a validation set, okay? So if you remember the splitting scenario, we can actually split it and have a somewhat a validation set, a test set, and then also a training set, okay? So let's try to convert it into XY variables where like file names can be X and then rest all can be Boolean labels, right? Cool. We already know length of file names is what? 10,000. Cool. Now, what we'll do is we'll basically, let's start with experimenting somewhere around 1,000 of these. Okay. Let's say start experimenting with 1,000 of these, and then we'll basically go uh, along the way, like depending on on need basis. Okay. So set number of images to use for experimenting. Cool. Then we are saying number of images is like 1,000 or something. Cool. Okay. Now we can use scikit-learn to actually split this data again. So if you remember scikit-learn, if you remember scikit-learn, okay, we used to use test split data, train test split data, and the ratio at which we are splitting is like 0.2, which is the same split sort of thing that we have been doing. But in here, remember, this is not a test data that we are splitting into. We are actually taking out a validation data set out of it. Okay, so let's see what do we get. So we have roughly 800 data points for test training, and we have roughly 200 data points out of this for validation. Okay, and we can see what this contains. Okay, these are all repeatable stuffs that we have pretty much done already. This is not something new that we are doing as of now. Okay, there are some few commands that will be new because we need to use TensorFlow and we need to think in a TensorFlow sort of way. Okay, for example, the next step where we need to pre-process images and turn it into tensors. Now, quickly answer me what are tensors. We don't have a lot of time, guys. I won't wait. Even wrong answers are fine. Just answer it quickly. So basically what a tensor is, just to give you, okay, generalize scalars, vectors, matrices to higher dimension, which is correct. Okay, so tensor is but just basically a mathematical object or basically a multi-way array data or something like that. Okay, you can say that, or multi-dimensional objects. Okay, um, where like you can denote um, these complex data cubes, as in, say, like you can imagine it as a three-dimensional sort of or two-dimensional sort of data cubes that you can actually represent. So you can say you have 1D tensor, you have 2D tensor, you have 3D tensor, you have 4D tensor, you have dimensional tensor, you have 5-dimensional, you have 4-dimensional, and so on and so forth. Okay. And basically what it helps us is to have some brief idea on like what sort of computation graph we'll have. Okay. So to pre-process our images, what are the different steps that we need? Okay. Um, and okay. So to pre-process our images into tensors, right? We are obviously going to write a function for it. We need to take an image file path. This is what we have been doing anyways. You need to use TensorFlow to read the file and save it to a variable image, which is also what we have been doing already. Okay, but obviously not using TensorFlow, and in this case we'll be using TensorFlow. Okay, now we have to turn our images into tensors. Now this is important to understand. So you understand what is a tensor. Okay, you can't exactly call it an array, but it is more sort of a multi-dimensional object. That would be much more appropriate to call it, because it has a multi-dimensional element into it. Okay, and what you need to do is convert these images into tensors, okay, which our TensorFlow model can actually, a TensorFlow library can actually understand. Then we need to normalize image, and by normalizing is we have to normalize it enough to fit into a model, basically convert color channels from value 0 to 255. If it is going beyond that, which is basically so if you remember, I don't know how many of you know the color code and scheming. The color code scheming number go from 0 to 255. 0 is like pretty much black and 255 is like pretty much white. Um, and there is this whole color scale around it. So you need to normalize all of these sort of things before doing that. Then you need to resize the image to a shape which is much more appropriate for analyzing this particular data. It can be to some X and X sort of sizing. Okay. And then we have to return the modified image. Cool. So we need to pre-process these images so that we can actually get some predictions out of it much more properly as we intend to. Okay. Cool. Now, if you guys remember, this 3 line sort of is like multi-line comments. Now we can use matplotlib, okay, IMRead to actually read a lot of these file names, and we can get some image shape to understand what is the current shape of the image. We need to convert it to 224 to 224. Let's see what is the do we have that kind of shape right now? Okay, we don't. It's like 257, 355. Not what we want it to be. Okay, so let's see. Okay, what is the max and min in here? And the shape is like 255 and 0. So we need to somehow actually transition it. Okay, let's see, what do we get from image here. Now you see that this image here and this IMRead, which is coming from matplotlib, also internally has and uses this uses basically numpy. Okay, and what it's saying, it reads an image from a file into an array. Okay, and basically this is a numpy array. Cool. And what it is giving you is like, it is giving you that image sort of metadata and like an array of it. Now let's try to turn the image into a tensor. And how do we do it? So there's something called as like constant that we can use from our TensorFlow. And if you remember, we have already imported TensorFlow and we gave it an alias name. Okay, alias name is more sort of a shorthand name. Okay, that is what we gave it, which is TF and hub. TensorFlow has TF shorthand name, and TensorFlow hub has hub sort of alias name. Okay, so we are using constant function from the TensorFlow, okay, to convert it into tensor. And it says, okay, it is converted into tensor of shape somewhat like this. Okay, now we have seen what an image looks like as a tensor, right? This is how it looks. It looks like a tensor. You can basically relate to it because it's still an array internally, but it is a multi-dimensional object sort of an array, okay, which represent some sort of numerical format. Okay, you can read more on it, like what it is and how it is converted and why do you need it. Okay, we'll just run through other details from here on. Okay, now we need to pre-process this, obviously, because we said that we need a shape size of 224 to 224. Okay, so we need to be ready to make that. Okay, so let's see how that function will look like, and this is how that function will look like. So the image size that we are expecting is 224, and this is the constant. If you remember the standards in the Python, this is how you define a constant, right? You are passing a default value parameter, which is image size, and then you are giving it an image path. And it says, basically documenting this particular function, that it takes an image file path and turns it into image into a tensor. Okay, so we are giving it a tensor. We try to read the file path, and how we are reading file via TF has something called as IO, which is input and output. Okay, and this input output have a function called as read file, which enables you to read file. Okay, then TensorFlow has another sort of function which is basically decode JPEG. Okay, and what decode JPEG does, it basically it converts or turns the JPEG image into numerical tensor with 3-color channel. And 3-color channel is a pattern. So all of you know that any sort of color format is actually made of 3-color combination, which is red, green, blue. So you can basically create any color with these 3-color combination. Okay, and I don't know how many of you guys know about it. If you have some sort of color blindness, then you're pretty much blinded by either of these one main color that you're not able to identify, and that's how you get these color blindness. Okay, so what it tensor does, it converts it into 3-color channel. Okay, that is why it says channels 3. There are different ways and format actually also to convert into color channels. You can read more about it. Okay, now what it does is we convert the color channel, okay, which we get from here, right? It is converted into some sort of color channel that we get it from here. Okay, and we move it values, so convert the values from 0 to 255 into a value format of 0 to 1. Okay, and finally we resize the image based on the image size that we want, and we want 224 to 224. That is the image size that we want. That's what this particular function does, right? Cool. By the way, does someone knows how to convert a cell into a damn sort of uh, ah, you need to add a text cell randomly. Weird. It's weird. It's sort of weird. Cool. Okay, you can't even do this. This is so automated. This is so damn automated. I don't like it. Okay, and this is but just useless. So turning our data into batches. Now, why do we need to turn our data into batches? So the thing is, I've also written it here. Let's say you're trying to process 10,000 plus images in one go. The point is you have very limited resource here, RAM and disk, you see, okay? You're not having like abundant of resource. Resources are not unlimited. Some people's system might be limited to some other category and some to other category. So what you need to do is you need to actually effectively use the resources that you have. And that is why what we try to do is actually we try to divide the data set into batches so that we can process it in a batch-wise manner, which basically gives us as much as performance as it can while still processing at a very good sort of significant speed. Okay. Let's create another sort of function that will actually return us image label. Okay. And very straightforward, we can just use process image, which is this function that we created, and then it will get us image and the label that we are passing in here. So it takes an image file path name associated with a particular label, and then it returns a tuple type, okay, basically a tuple type of image and label. Okay. So let's test if our process image sort of works or not. Okay. Let's test if our process image function, which we created earlier, works and actually converts the stuff into the shape, which is 224 x 224. Okay. Color channel 3 and tensors, does it do the conversion right? And if we see this, 224, 224, color channels 3, and then yes, we get some array data points and all. Cool. So this works. Now, we have got a way to turn our data into tuples of tensors, obviously, in the form of image and label. Now, what we need to do is we need to make a function to actually turn all of our x and y into this tuple. Cool. Okay. So it's a very Pythonish sort of straightforward function. Okay. Not a very complex stuff. It's just might feel a bit verbose, but it's not so complex. The idea is what you do is you set a batch size. Now, batch size 32 is much more a standard sort of batch size. Okay. You can increment at the rate of 2, at an exponent of 2. Okay. So it can be 64, then 128, and so on and so forth. Okay. And see how is it processing, and is it processing fine. Okay. Then what we are doing here is like we are creating a data batch size, okay, because we have to convert the data into batches, and that is what we are trying to do. So we pass a default sort of parameterized function where we are saying like batch size is batch size, y basically label is none. We are passing a lot of features into here. We don't know what is the valid data, we don't know what is test data, and by default it is false. Valid data is by default false, test data is by default false. Okay. Now, if the data is a test data set, we probably don't have labels. Okay. If you remember in scikit-learn, if we are doing some test data set, we never used to have labels because labels are something that we are actually supposed to predict. Right? Now, what are we doing here? We are using a function from TensorFlow to manipulate the data, and we can target the data set, and it says that we can create slices, or in this case batches, okay, and we can use again a function called as constant to actually convert it to tensors, and we are passing it x, which is our training feature set. And then in here in the next line we are saying create a data batch if it is a test data where we don't need labels. Okay, map processed image. Okay, in here map the processed image. What is the processed image in here? Process image. Okay, process image is basically the function. Okay, and then batch it to batch size. Cool. We are mapping and we are passing the map. The process image function, if you remember, the process image function is here, which is doing what? It is pre-processing the image and convert it into the desired shape that we want, okay? And in here, we are trying to trigger that function, hence we are creating a map of that function for the batch size of 32. So we are doing it like 32 times. Is this understandable? Do you guys understand the logic that is happening in this particular code block? Yes, no. We have already covered somewhat. What is a map? Okay, what is a map? Define like Python maps. How does it work? How does map work? Answer fast. How does map work? How does map work? First, tell me how does map work in Python. Explain me how does map work in Python. I want to know how does map work in Python. How does map work in Python? Munawar Basha, it is not your dating site that you're like just randomly asking where are you from to a person who is supposedly asking questions. Can you just be serious and respect the forum that we are on? Like seriously? Okay. So the function defined is applied to each of the element in the given iterable. That is cool, but I want to know what is a map. A map function applies a given function to each item in an iterable and returns an iterator of the result. Cool. Exactly. So what are we doing here? A map function applies a given function, okay, to each item, which is the batch in here, to each item. How many items are there in each batch? 32. So it applies, this function applies to each item in an iterable, which is this. This is basically an iterable because it is an array of batch size 32 and returns an iterator of results. So it will apply this process image and basically it will return the iterator. Okay. By your definition itself, I am explaining it. Now, is it clear? What about rest of the people? Only Trish is clear? Read that map definition again to understand it. Break it down here. Map applies a given function to each item. In this case, we are basically batching into 32 size of batch. So it applies to all of these 32 items, okay, which is also an iterable. And we already know what is an iterable. Since we have read Python, I won't revise that, okay. And it returns an iterator and while applying that function that we passed into this map. Cool. Now, obviously, test data does not need labels, okay. Now, what is if it is we are basically testing with a valid data set, okay? We don't really need to shuffle it, okay? And what we'll do is like we'll create a validation data batches, okay? Batch size is again 32, cool. And we are saying, repeating the same thing using tensor function to create slices, but in here, because it is a validation set, and we will basically validate our values against the predicted values. Okay, we already know the labels beforehand in a validation data set. In a test data set, we don't, because we are making some sort of prediction. In a validation set, we know it, even though it is still a test sort of data set, but we know because we are supposed to cross check, validate before we are basically applying these models onto um, the test data set. Okay, henceforth we can, and we also need to convert labels also into tensor. Okay, and then we repeat the same map function and create a data batch. Is this clear? Only one person has said yes. Answer it fast. Answer it fast. Answer it fast. Guys, am I audible? Yes, no? Then why the hell can't you guys answer me the fact when I am asking you guys since literally 5 minutes that do you understand this stuff or not? The answer is either yes or the answer is either no. But you guys are like not even responding to it. So if you don't understand it, just write no. If you understand it, just write yes. What's the point of like just being silent there and not really understanding anything? If you guys will be responsive, then only I'll know, right, if you understand it or not understand it. So I'm asking this question again, and I want this answer again. Do you understand it? Yes or no? Okay, you don't understand it. Cool. You understand that what is a map function? Do you understand what is a map function? Yes. How many people of you understand what is a map? Okay, everyone understands what is a map. Okay. You guys understand map takes a function as a parameter. Yes or no? You guys understand map takes a function as a parameter. Answer me yes or no, fast. Yes, okay. Now you understand we created two functions, that is one, get image label, and there was another function which was process image, right? This is one function. This basically pre-processes image and converts into shape 224 and 224, right? And this is the function that basically returns a tuple or tuple of image and label. This is clear. We have these two functions, get image label and process image. Yes or no? Yes or no? Type it. Yes or no? Yes. Okay. We are passing this function because map takes a function. You understand it? Yes, no, yes, cool. Okay. Now we are applying it to this data. We are applying it to this data, which basically contains tensors. We have converted it into tensor slices, right? Tensor array. We understand this, correct? We understand this line, right? Pretty straightforward, coming from TensorFlow. We just converting it into tensors. Cool. We are saying that we are applying this function to each and every element of this particular data, but But because applying it to all 1,000 data points at once is a very huge task, okay, what we said and agreed that we'll basically split into a batch size or a bucket size of 32 element at once, and that is what we'll process. TF constant x actually converts x into tensors. And I have already explained what is a tensor. Okay, this is clear, right? It's clear. It's clear up until this point that why do you need batches? What is this batch size? It's clear. Cool. Now we are saying there's this batch function. We are saying map has a batch size of 32, and then it is iterating over each element in this batch size. Understood? Now, do you understand this? Yes or no? Oh, okay. Be responsive, guys. You guys expect me to be interactive, but you guys are not even responsive. Then how does it like work? Okay. Now all of these remaining data set actually works the same. Okay. The remaining ones works the same. The only thing is like somewhere we are basically getting labels, and at the end of it, basically we are basically splitting it into three sort of blocks. One is validation data set, another is test data set, and finally some training data set. And please, whoever the Samsung SME236B is, just message to Blackbucks, guys. Don't bug me with attendance link. I am not responsible to take and give you attendance link. And if you have attended the like 16 sessions in the past, you should have known this by now. We have less time to complete this topic, and you guys are like literally being so uninteractive and like still doing the same sort of things. I don't know if you guys even want to complete this topic. Cool. Okay. Now we have this training and validation data branches, right? And now in here, we named our function as create data batches. If you notice it, and that is the function that we are calling once we're training data set, which is what we are not giving this false because the default value is false. So by default, it will trigger this part, okay, wherein we'll basically map and get image label, okay, in the batches. And then for validation data set, we are saying that, okay, we need validation data set and we're changing the default value, which is false, to true. Okay, this is just basic Python that we have already covered. Now we created a validation data set. We also created a training data set. Now what we are doing? We're basically using training data, okay, and getting element specification out of it. Okay, and let's see. So if you see now the data has been pre-processed and the images are in shape of 224 cross 224 and color channel 3. Right? Right? Now let's try to visualize it. Okay, and for that, we'll try to create another function. Okay, and we'll try to see these images. All it does, it basically plots the graph using myplotlib basic interface that we have been using in the past, using myplotlibs, hence why I'll just skip it and not explain you, but this is just understandable. Okay, cool. So if you want to see these images, okay, maybe what we can do is just see like training images, and we can potentially see like Now we can select roughly 25 images. This is here using matplotlib, and you can see that we can see different type of breeds of the dogs, and then we are able to visualize. Nothing special that I'm doing, and you can do and repeat the same for the validation data set. Cool. Now, what are we supposed to do? We are supposed to actually build a model. Okay, so what we'll do, we'll build a model. Cool. We'll try to build a model. And there. So before we build a model, okay, we need to define few things. The input shape, our images are in the form of tensors to our model, right? That's why we have been converting it into tensors. The output shape, which is image labels, are also in the form of tensors. That is why we have converted that. And the URL of the model that we want to use from TensorFlow Hub, okay, will be somewhat something like this classification, which we are getting from TensorFlow Hub. And we get it from there because ideally the model is quite heavy, okay? Hence, we just use the URL to get that model, okay? Now we know the input shape, and we are basically using the same constant and so on and so forth. Batch size, image size, so on and so forth, okay? This is all the same thing, and model URL. So defining some constants, and these constants we might be reusing. Right. Now, what we need to create a function to create a model, okay? And what does this function do? This function does the following things, actually, okay? It basically, it takes the input shape and output shape and the model that we have chosen for the parameters, defines the layers in the Keras model, okay, in sequential fashion. So you have to do this first, and then this, and then that, which is what sequential means, like one by one by one. Okay, then it compiles the model and says it should be evaluated and improved. Finally, it builds the model, and then we will return the model that we'll be using. If you remember, it was very simple and easy. In scikit-learn, we were just using out of the box scikit-learn to get the model. In here, we have to do some more polishing to get that model. Okay. And this is a very simple function where like we can do it. The three things, which is the default parameters that we get in here, which is the input shape, output shape, model URL. These are the constants that we already defined here, and we have been seeing up until now. Okay. Now what we do from TensorFlow, we are using Keras, and we are saying, okay, it has to be sequential, okay, which it has to be in sequential fashion. That is what we said in this particular file, okay. And we are saying that use this particular model URL that we are supposed to use, and it will be supposedly a dense type of layer, and we are expecting the unit of this particular output shape, and the activation is of type softmax, okay. And I remember yesterday I explained you what are these activation types, so I won't explain it again because we are low on time, okay. And you can refer to previous class. Now, finally, we compile this model given the above value, and we say, okay, if we have some loss sort of metrics, okay, then it can be a categorical cross entropy, which is very similar to what we were doing before. If you remember the metrics like MSC, MSA, and so on and so forth. And we have to use optimizer to actually optimize this model. Again, we get, this is all the straightforward functions that we directly get from Keras, and all it does, if you see and hover over it, optimizer implements the ADAM algorithm. And this is basically an optimization algorithm based on stochastic gradient descent method that is based on adaptive estimation. Okay. Now, there's a lot of maths involved in here, which you will have to read about if you really want to understand it in depth. But by default, you can just understand this is what we are using out of the box from the Keras. So let's create this model. So obviously, we just created the function, but we also need to call the function to create the model, and boom. and it's saying we are building the model. Okay, it will take some time. The model is sequential, and we basically built this model of Keras layer this. Okay, it is of dense type and so on and so forth. Okay, and it tells you what is the sort of memory space it is taking to work on it. Cool. Now we can create a callback function, and callbacks are basically helper functions a model can use training to do such things as save its progress and check its progress or stop training early if a model stops improving. Okay, so depending on how the model behaves, it can behave as such, and that is why we'll create callback functions. One would be TensorBoard, which will help us track our model progress, how our model is progressing. And another one is for stopping the training early on if we know that, okay, the training is going for too long and we just don't want to train it anymore. Cool. Okay. So we can just load TensorBoard, and it is already there, and we load this. Cool. It is just an extension that we can directly get from, I don't know what you are talking about, Suhana. I honestly don't know what you're talking about. Probably this is something that Blackbucks can help you. So this is where you get TensorBoard from. That's why we can use this as an external extension. Okay. Now I said that we need to create two functions. One is obviously for tracking our progress. Okay. So we track our progress. What is that? We are saying, okay, copy path, and we basically copy the path in here as such. Okay. And we said boom. Okay. And another function, again, which is also something that we can get from Keras, okay, which is also from Keras, is this, early stopping. It helps us stop our model, and you can again read it in the TensorFlow. Obviously, I'll be sharing this notebook later on. Cool. And this is how we can use it. Cool. Now we need to train our model, obviously, okay, because of all the work that we have been doing up until now. So we need to train our model, okay, on the subset, okay, and we'll basically train our first model on thousands sort of data set. And the process is very similar to what we have been doing up until now in scikit-learn, okay, which is like this. Like we basically create a model, then we are doing this, calling this callback. Okay, this is the only different part. We are calling this TensorBoard callback, which we said that this is to progress the model, progress, and then we are fitting the model and return the model. Cool. So what we can do is we need to fit in the model, right? We need to call, and we can just call it, and we can see how the training goes on. What does it say? Num epochs are not defined. Okay, we need to define num epochs, right? So we can actually define num epochs, which we said will be roughly 100. Okay, so epoch can be 100 by default. It's just a constant number that we need to pass in here. Okay. And now we should be good with it. And now you see what the epoch does in here. So it will take some time. Cool. Okay. We'll check in the progress using basically TensorFlow board. Right? And if you see, okay, it looks like our model is basically overfitting because it's performing far better on the training data set than the validation data set. And how can we say that? Because like the accuracy is like way too high. You see, 1, 1, 1, 1, 1, 1, 1, 1, 1. This is not something that should happen. Okay. And that's how we know that this is overfitting. And we need to actually, so overfitting in general is good because it means that our model is actually learning, but we also need to check on logs uh, to understand, okay, what happened. So what we'll do is like we'll check on the logs. Okay. Um, okay. This was not the path actually. The path was I need to get the path from here. So the path was as such, and I'm pretty sure it won't work. Probably. Or it will. Let's see. Let's see how it goes. And now you see that using this whole tensor board extension, we can look at a lot of details in here, like epoch accuracy and stuff, how our training data set is performing, how our validation data set has performed, and so on and so forth. And this is where the logs actually are. And it tells us a lot of these details, like, okay, how was the accuracy like? How was the, okay, how was the evaluation step and so on and so forth like? Cool. Now, we need to make and evaluate predictions. Okay. So we need to do this. Okay. And we remember we had some sort of validation data set. Okay. Which is obviously a batch data set. And let's try to make predictions and see. So we created a model, definitely, right? This is the model that we created. In here, this is the variable. And via the model, this is the same. We actually predict, okay? And we are like trying to predict it. And let's see what the predictions that we get. Cool. And we get a lot of gibberish data that we don't understand anything about. Let's try to trim it down to one data point, and you see that, okay, it is an NumPy array, which has, again, a lot of gibberish data, which we don't understand. So what is the basically the prediction? Because why this is the image that, if you remember, we converted into numerical time. That is how and why it is showing the way it is showing right now. Cool. So to understand and make more sense of it is, obviously we get the gibberish data, and then we get, if you remember proba predict, we are getting probability of the prediction, which is like somewhere around 0.64, roughly 64%. The sum is around 99, max index is 113, and predicted level is Walker Hound. So we basically predicted the image to be Walker Hound. And let's just now cross check, because we had this unique breed label, and let's just say that did we predicted it right? okay? The index was like 113, and that is what we are passing here. And guess what? It is walk a hound. So having the above functionality is great, but what we want is to be able to do it at scale. And it would be better if we could see the image. The prediction is being modeled on, but we definitely need to see the image, right? This is just gibberish right now, right? So let's try to get something out of it. Let's try to get something out of it. And we create basically a function. And boom, we get a label, which is some sort of like dingo, pingo, whatever. Okay. Now, since our validation data is still in batch data set, we'll have to unbatchify it, right? We create a batch of 32s. We need to like unbatch it, okay, to make prediction on the validation images and then compare those prediction to the validation label. So let's see how we can do it, okay? So we have this batch data set. So let's create a function basically which will unbatchify the batch data. And this is how we can unbatchify. It's just right off the bat, like direct function to just unbatch it. And then we iterate over image and labels after unbatching the data, the batch data. Okay. And and basically, if you remember, as NumPy iterator, this is how we basically create an iterable on which we can iterate over. Okay, and we return a tuple of images and labels. And let's see what do we get. Cool. Now, we have got ways to get prediction labels, validation labels, which is true labels, right? Validation images. What we need to do more, we need to make functions where like we can visualize this a bit more, okay? And what we can do, we can take an array of prediction probabilities, obviously an array of truth labels and an array of images and an integer, convert the prediction probabilities to predicted labels, right? And then plot the predicted label and its predicted probability, which is the truth label and the target image on the single plot. That is what we want to do. Cool. Oops. Oops, 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 oops. Cool. So, cool. Now, let's try to create a function where like we can plot these images again, but based on a prediction probability. Again, you have already seen all these matplotlib function. The new thing that we are doing here is like passing in prediction probabilities, actually, as you can see in here, okay? And then we are just plotting the image, okay, which we get and pass in here. So it is all matplotlib thing that we have already done. Now, what we'll do is we'll plot by passing in prediction probabilities, which is our predictions, which we got from where? We got our predictions from where? We got our predictions from here, right? Predictions. We predicted a model and we got our predictions here, right? And we are passing that prediction in here as prediction probabilities, and then basically we are passing labels. Labels also is something that we actually got it when we used unbatchify function, and we basically unbatchified images and labels, and then we basically pass the unbatchified labels, unbatchified images, and then n, okay, which is 77, okay, is just a number. So we can see, okay, it is just a number that we are basically passing down to give us the value. So let's see what do we get out of it. And boom, this is what it says. Cool. Two, can we let's try to do this. What does this N5 does? 88. So N is basically trying to say that, okay, plot this specific image and tell me how much, what is the probability of matching the particular image that it is predicting. So basically we predicted Norfolk Terrier, and it is saying there is a 44% probability that it is a Norfolk Terrier, right? So that is what is N here, number of image. It says it is a 33% probability that it is miniature Schnozoar, but it is Carn. So actually, this was a false prediction. It didn't predict it right. So when it shows it red, okay, this is what we have defined all of this here. So basically, if the prediction level is right, then we show it green. But if it is wrong, we show it red. Okay, so we have actually said all of this here. This is pretty cool, right? I find this pretty cool that we are able to predict all these images, classify images based on TensorFlow, right? We can actually do some more advanced graphing around here to get predicted label, get the top 10 prediction, and so on and so forth. We can basically get a bar graph uh, to to get much more metadata around it. Okay, let's see. You see, like how and what your prediction is. So we are saying that we are taking a guess that it is like, so if you remember, okay, let's try to see what is the probability of the bad prediction that I think so it was 22, right? So let's try to make it 22, and we can see, okay, what was the second number? So Cairn is the right one, and that was like second top on our list, but like the first top was basically wrong. So there are things that we can do. Maybe we can provide it with like more of these images to actually improvise the prediction. Cool. So now we have a lot of function in here, and we can possibly do something like this, which is showcase a lot of images and graphs and a lot of predictions as such. You see? But the second number was of this is right. So what we can do is like we can possibly give more images of this particular dog to improvise the prediction, and some of these predictions were really right. Right? Now, finally, what is always the last step of this whole flow? Okay, last step of this whole flow is always that we save our model, right? Last step of this whole flow is always that we save our model, right? Which is as such, and we can just save our model using the OS package, and let's see. Boom, we saved our model, and we can actually load our model by using this function again, using TensorFlow Keras. Cool. Cool. And then possibly what we can say, okay, just save this model, and say it is like this. So it is trying to save the model. Cool. Okay. And we can actually test the loaded model. Okay. So what it is saying is, let's just load this model. So it saved it to this place, right? Adam. Let's try to do it. Cool. And let's try to load this model. Boom. Okay. It doesn't work because we are not giving it less level. Load. What does it say? It says that was not able to find this particular stuff. Okay. This is the model. We can just copy path just to be sure. Okay. Let's copy the path. Now it should. Okay. It works, right? We loaded the model and let's try to evaluate with our validation data set. And boom. It works, right? It works. It says like the accuracy is somewhere around 67.5% or something. Okay. What else can we what else can we do? So load it. Okay. What do we get? We get the same thing, right? Because we saved our model. Cool. Now, what you can do is you can repeat the same process. You can pretty much repeat the same process. Okay. But on the full data set, I only did it for 1,000. You can pretty much do it for like whole 10,000 sort of data set. Okay. And it involves pretty much the same steps. Okay. Only one extra step that is involved is having a test data set. Okay. So what we can do, actually, I can quickly run through full data set. I don't mind. Okay. So, boom. Let's try to get full data set. Okay. Full data. Okay. Let's try to get full model. Okay. Let's try to get full model. Okay. We are building a model on a complete data set. Okay. Now we need to get full early stopping, full model, TensorBoard, and so on and so forth. Okay. And then we need to fit in the model. These are the same process that we are basically repeating now. The only difference is right now is that we are doing it like for complete data set. Earlier we just did it for like 1,000 data points, if you remember. Okay, now this takes a bit of a time. Okay, guys, if anyone has any question, you can just like type your questions down there. But most of it should be very straightforward because a lot of this you have done throughout the course. I think we did a lot of scikit-learn, and scikit-learn had pretty much this very similar process. There are few things which are different than scikit-learn, but it's man, I don't care if you give me a 0 rating, but like Bharat, why are you just being stupid, man? I ask you, I ask you after completing a topic that ask me questions on the topic, and you ask me what is the topic name. Plus, I wonder how you guys are not even ashamed to ask that. Don't you guys feel some shame when you are asking like topic name at the end of the class, when the whole class is completed? Like I'm only talking to those people who actually ask this question. So no one has any other question? No one has any other questions? Okay. Now there are a lot of things that you can perform, and because there is not enough time, and I already said it beforehand, even before the course, that I won't go too in depth into deep learning and show you a lot of examples, but I have pretty much covered a lot of important parts of it. Okay. Uh, Epoch is basically the number that we want to train these models on. So it keeps on training on different sort of data sets and number up until it feels that, okay, the training is not yet done. So we just give some estimated number of epochs for how much time it has to be reiterated and trained on this unstructured data. It has to be done multiple times, right? But that is why we created this function where, like we said that, okay, it might end up in some sort of endless loop. That is why we created this function where, like, which is an inbuilt function where it will just stop early on, where it feels like it is going into that endless loop, and you just are trained enough and you don't really need to train more. Okay. So I already told this before starting this class that I won't go very broad, as broad as what we went in scikit-learn, that we won't do it on deep learning, but pretty much I have covered the same things. And um, it takes time. Even here you see how much time it is taking, right, Raja? So there are projects that you can do easily with deep learning. Probably there is a deep vision project that you can do, and that is what also you will get in your assignment. Uh, and this will actually robust your knowledge of what has not been really taught in the class. So a lot of has been covered, and there will be some parts that you will have to research around it to complete that specific assignment. I don't even know what is assignment 3 and 4. I mean, if you tell me what is the assignment about, then maybe I can tell, but I don't know what is assignment 3 and 4. So see, this is pretty much endless. It keeps going. 10,000 years later also, it will keep on going. Okay. Okay. The idea is when you are submitting on Kaggle, okay, I'll just tell you because I don't know when it will complete. If it doesn't, this is a bit slow of a process. Okay. But the idea is when you submit it on Kaggle, and if you start doing some Kaggle things, okay, you're supposed to convert your predictions into a data frame, okay, which you already know how to convert things into data frame, okay, and it will expect your prediction to be done on the test data set, okay, and then you can submit that. You are saving it so that you can retain it. That is the whole logic, right, Raja? Why are we saving the model? We're saving the model so that you can reuse it. You don't really need to repeat all the other steps that we did. So even after 20,000 years, it's still running. If you have any questions, you can still ask because I don't know in which year this will be completed. Why can't we take 10 or 20 epochs, sir? I mean, you can take 10 or 20 epochs, but it will just not be a well-trained model. So what is Spotify likeliness classification analysis? Where to extract data? Now, I think that particular assignment is not really given by me if it is something that is provided to you to predict Spotify likeliness. So I don't even know where that data set is. I haven't done any research on it. I can tell you how you are supposed to classify it, but I can't tell you where to get the data from. You are supposed to ask the Blackbucks team if that is what you don't have that particular data set, or pretty much they might have given some sort of direction, or that data should be readily available. but you are not able to find it. I don't know. I don't know all of these assignment questions. I don't know. Okay. Yeah, finally, at Epoch 21, this is done. Yeah, after 20,000 years later. Cool. Okay. So what we can do, you can use any data extraction. I would say go for the projects where you get data set easily. Cool. So after doing this, we can repeat the same thing, which is like save the model, and let's just try to save the model. Okay, we'll try to save the model, blah, 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 but this is not saving the model. Why is it not saving the model? Because we don't have the brackets. Okay, cool. Now you can see we are able to save the model, right? And we basically have cool. Now the same thing what we can do, but now what we need to do, we don't have labels for which sort of data set. We have that labels, we have that labels for, we don't have labels for test data sets, right? So we need to get test data set, and we already have been given by Kaggle a test data set where we don't have any labels, which is present in our test folder, and that is what we need to make predictions on. So you remember that we didn't split our data set into a test data set while in scikit-learn we were doing it, because what Kaggle does is it provides you your test data themselves, and it asks you to give predictions on that so that they can make an analysis and provide you some sort of judgment on it, if that makes sense, right? So uh, let's try to get the test path. Okay, test path, and let's try to copy this, copy path, right? And we'll just copy this. Cool. And then we can do the same magic to get the file names and stuff that we were doing above. Okay, there. Okay, how many test data do I? Oh, we have 10,000 test data that we need to make predictions on. So let's create the test data. We already had created all these functions, create batch, and you're just basically using the same thing that you were applying to your validation data set. And I already explained it. You basically repeat the same process but what you do on your validation data set. The only reason why you create a validation data set is you can actually cross-check your result and actually improvise your model. Okay, so we create batch data set. Okay, and then we can actually try to make predictions. We can try to make predictions here. Boom. So we made predictions. Now what? Okay, now what? We have made predictions. Now we can actually save these predictions. We can actually save these predictions in our same path that we have been saving all our data into, right? In here. Cool. And let's try to save it. And using NumPy and save text. Oh, okay, it is predictions. Cool. We save this. Now we can load the same predictions. We can load the same predictions, right? That we actually saved here with the same path. right, with the same path as such. Okay, and we can see all these predictions in here as such, but it will give you all gibberish value, which you don't understand. And that is why you need to actually, you can see the shape and stuff, right? It has a lot of data, but it is all gibberish. Now, because in Kaggle, you are expecting a data frame, you need to, I said that you need to create a data frame out of it, right? So you'll create a data frame, right, with unique breeds and stuff and so on and so forth, and yeah, a lot of table as such. And what you will do, you'll try to create, you'll basically try to create a test data set and as such. Cool. And then you make these predictions. Boom. And you see so much of okay, which makes no sense. So you have to add the prediction probabilities, correct? That's why you will add test prediction probabilities into it, okay? And now you start seeing some gibberish numbers, which you still don't understand, okay? But you need to save it, okay? What you can do is now save these prediction numbers again, okay? Into the same path that we are basically, we have been saving to, okay? There, cool. And finally, okay, what we can do, we can get it again, okay, from what? We can, what we can do is like we can get dog photos, okay? We can define some custom path, which is obviously the same path that we have been using here, okay? This is what we'll say, cool. And that's where we'll basically save our images, cool. Oh, what does it say? Probably we can just create a new folder. Yeah, my dog photos. Let's just do it and then see. If we got this my dog photos thing, right? Copy path. Yeah, cool. Okay, then we see what do we have for custom image paths. And okay, it is a bit empty. Okay, first for whatever reasons. But what we need to do right now, we don't have any images. I'm supposed to have some images in there. Okay. And eventually you can do some plottings, you can do some predictions and so on and so forth. Actually, this is the data that you need to upload to Kaggle. Okay. You can actually look more into the Kaggle and how you're supposed to upload it and make predictions on top of it. And this is pretty much it. Now, if you have any questions, I'll just stop it here. If you have any questions, you can ask me in these final moments. And what you can do is you can actually okay, you can actually get this whole notebook, okay, in the this is pretty much being saved in the drive, right? So you can save this directly, right? Or I can just save it also locally if I want. Okay. This is all in the drive. And what I can do is if I go in here, right, I saved it in this location, you should be able to find it. I think in my drive. Let's try to look for this particular notebook that we have. So let's try to save a copy in Drive. Notebook copy complete. So let's open a new tab. Okay. And that's how you save it. And I'll eventually share you this note. Thanks a lot throughout this course for your patience, and to some people for asking me like some stupid questions at times, but otherwise, thanks. Right? You can still reach out to me, okay, via email. That is, if you have some specific questions at some point of your time. Ideally, Twitter is the way to go. Reach out to me on Twitter, okay? So this is my Twitter. So this is my Twitter that I'm sharing with you guys. This is my Twitter handle. If anyone has any doubts on any specific topic, you can just reach out to me on that particular on my Twitter handle, and I will try to answer based on my availability. Obviously, don't reach out to me for assignments because I can't help you there, but you can reach out to me on other machine learning sort of problems or whatever I taught, and some specific topic was unclear to you. You can just ask me some small questions and I will be more than happy to answer you. Okay. So that's basically my Twitter handle. Okay, that's basically my Twitter handle. I'm sharing it again. And I hope if you want, you can just ask me on Twitter. Okay, you can just ask me on Twitter. Twitter is basically the most easiest way to reach me out. Do remember, I won't be able to respond to you on any other platform. I'll only be available on Twitter. I'll be only available on Twitter. I keep saying this because maybe you might message me on LinkedIn, you find me on LinkedIn, but you won't get any response from me on LinkedIn. Okay. So this is my Twitter account. I am again sharing it. Save it if you need it. If you don't need it, you don't need to save it. Do whatever you want to do with it. Okay. I'll be sharing the notebook soon. Cool. Thanks for calling my voice sweet. Cool. Okay. Bye, guys. I hope you guys didn't mind. At times I was annoyed. At times I was very happy. At times I enjoyed this whole process a lot. And I hope you guys learned something out of me. I have also learned throughout the process a lot. I hope, because there's obviously a language barrier. So some people, most of the people here speak Telugu, and I know I can't speak Telugu, but also there are a few people who don't understand Telugu, but I'm sorry for that. I don't even live in actually South, all right? So I basically live in Central India, and I'm from Central India. So thanks for bearing with me and like trying to cope up with my English. I know for some people it might be hard to actually understand that. So yeah, but I hope and wish you luck for your future. And do keep in mind that you will have to practice a lot, because we have only touched the surface, and this does not really give you full knowledge. What this gives you is somewhat a path to actually approach your problems and solve your problems. It completely depends on Blackbucks when my notes will be available, right? Completely depends on Blackbucks. I believe the the assignment that I'll be giving you on the deep learning part would be a bit complex, but I hope you guys do it, because if you do it, you'll understand deep learning in a much deeper detail. Okay? Okay, guys. So yeah, thanks a lot. See you. Bye.